In step 1, in step 2, we want to make the assumption that's true for n equals to k. So this is what we want to prove. We want to prove that 4 to the power of n minus 1 is greater than n squared, and it's for n is greater or equal to 3 by mathematical induction. In step 1, we're used to using n equals to 1, but here it specifies that n must be greater or equal to 3. So we want to use the smallest number in that, which is your n equals to 3. So we want to show it's true for n equals to 3. So our left-hand side equals 4 to the power of 3 minus 1. That's 4 squared, which equals to 16. And our right-hand side is just 3 squared, which equals to 9. So therefore, 16, it is greater than 9. So left-hand side is greater than right-hand side. So therefore, it is true for n equals to 3. In step 2, we want to make the assumption that's true for n equals to k. And for inequalities, we just do what we normally do, just substitute it in for k. So we assume that 4 to the power k minus 1 is greater than k squared. As always, we do use this assumption in step 3. So we want to keep our eye out for when we can use this assumption. Now in step 3, we show it is true for n equals to k plus 1. So we substitute in k plus 1. So over here, if we have k plus 1 minus 1, that's going to become 4 to the power of k. And here we have n squared, so that will be k plus 1 squared. So this is what we want to prove. We want to prove that this left-hand side is greater than the right-hand side. So we start off the left-hand side equals to 4 to the power of k. And we can change that into k minus 1 plus 1. And why we want to do that is we think back to our assumption and we have 4 to the power of k minus 1, right? So we know we have to work that somehow into this. So that's why we make this k minus 1 and we balance it with that plus 1. So this is the same as writing 4 to the power of k minus 1 times 4, because that 4 to the power of 1 just becomes that times 4 there. So this is the same as that. And so how do we incorporate an inequality into there? Because we can't quite substitute one side into that side. But what we can consider is if I have the assumption that 4k minus 1 is greater than k squared, then if I multiply this side by 4, then we have to do the same to the other side, and we can still make the assumption this is greater than that. And that's exactly what we've done here. We've used this to say that this must be greater than that based on the assumption that 4 to the power of k minus 1 is greater than k squared. So this is the first difficult part that students struggle with, which is how do we even use this assumption? And that's just by balancing those two sides. This is the other difficult part. How am I changing this into that? So how do I change this left-hand side to even remotely look like the right-hand side? Well, this is 4k squared, isn't it, when I multiply it? And I've just separated that into k squared plus 2k squared plus k squared. I've just separated into that. With the right-hand side, it's k plus 1 squared, which is, when you expand it, going to be k squared plus 2k plus 1. So I'm always looking at this right-hand side. This expands to this. And I can say that this is definitely greater than that because this 2k squared is greater than 2k. K squared is greater than 1 in this case because we know that n starts with 3. So 3 squared is going to be greater than 1, 4 squared is going to be greater than 1, so on. So we have two values that is definitely going to be greater than the other side. So that's how we can make the conclusion that yes, k squared plus 2k squared plus k squared will be greater than that. But can you see how I needed to separate this to look like this? So I can say that this is greater than that and that is greater than that. So I'm showing the examiner that I understand how this is greater than that. And now I factorize this into the right-hand side and that equals to the right-hand side. Don't be confused. You have equals to the right-hand side. So it's not left-hand side equals the right-hand side, even though that's what we end up with. We have left-hand side equals to, but we have a greater than there. So left-hand side is already greater than whatever's left, and then equals to again, and another greater than. So essentially we're saying left-hand side is greater than all this, as well as greater than that. So that's how we can make the conclusion that therefore left-hand side is greater than the right-hand side. Therefore, it is true for n equals to k plus 1. And we write our conclusion, which is therefore 4 to the power of n minus 1 greater than n squared is true for n is greater or equal to 3. Okay, so important things I want you to remember is how we substitute in the assumption is just by manipulating the assumption itself here and substituting the whole thing in. And the other thing is to look out for these greater than signs. Even though we end with equals to right-hand side, we have to look at the entire equation that we've written out and see if there is one or more greater than sign. We can conclude that yes, the left-hand side is greater than the right-hand side.